Okay.
Hello.
Just take your ruler and draw a line from O out to the edge and hit anywhere on one of those straight lines. Straight parts of the circle. Is everybody good? So all of you, somewhere in your circle, have drawn this line that I have here. Yeah? Excellent. Now, what have you just drawn?
A radius.
A radius.
Or not the eyes.
Now, everybody measure your radius.
Sounds like a
It's the only thing you have to measure, buddy.
I got this thing.
That's a protractor. It does angles, not distances.
It's an angle of a straight line, which is 180 degrees.
But I didn't
Yeah,
want that.
Mine's
3.5.
8 centimeters.
Exactly?
Yeah.
Cool.
Mine at 3.5.
Yeah, mine's like 8 and like
You start at 0.
8.8.
Of course you start at 0.
Same. Mine's 7.5.
What?
Or 8.
Mine's 8.8.
8.7.
Mine's 7.5.
Yeah, mine's 8.7.
No, it's not.
That is.
No, it's not.
You know how to measure? Oh! Look at that.
Help a brother out, Riley.
Yeah.
I'm helping out other Yep. What is it? You're on the wrong circle.
Come on.
His circle's small.
Oh, is he on the end of the page?
Yeah.
Yeah, that's why.
Find the other one that's in here.
It'll be after the definition decoder pages, Perry.
Oh, I'm sitting on my.
There it is. All right.
That's why.
Is everybody good? Of the people that have measured their circle, their radius, what do you have?
8.7.
And Bryn had 8.7 and Kobe had 8.8. Kobe had
I had 8.7.
8.7. Great. So the point I'm trying to make is, once again, these are all within a millimeter of each other, right? All these radii are the same. No matter where you drew it, it's the same, isn't it?
Yeah.
If I draw another radius to any other point in the circle, how long will it be?
The same.
So we know that this is 8.7, yeah? And then any other radius that we draw, no matter where we put it to, is also going to be 8.7. Is everybody cool?
Yeah.
So that is lesson 1. All radii are the same in the circle with which you are working. Understand? How many radii can a circle have?
Infinite.
Infinite radii. Understand? And they are all what length?
The same.
The same. In this case, they would all be what? 8.7. Agreed? Everyone cool? Okay. Now, I want you to take your pen or pencil, and at the dot that you, or at the point where your radius that goes out to the straight line, the first one we drew, I want you to label that A. Everybody Gouda? Now, take your ruler and make a straight line that goes all the way along.
Oh, I have a 10.
This is tough to do. Make sure your straight line lines up perfectly with the straight part of the circle. It's really hard for me to do on my computer, okay? But you guys can just lay your ruler along this line right here. Do you all see what I am doing? It won't work very well for me, but you guys can do it really easily.
Is this called a tangent?
Make sure that it goes just along the line that is flat there. So it only touches the circle along that straight part. Everybody Gouda?
Great.
Great.
Wonderful.
Name that point out there Q.
That's a strange one.
Okay? What would be the name of this line from the point on the circle out to Q? That is QA. Cool? QA is a tangent. Please highlight that word. A tangent touches the outside of a circle once. Everybody cool? Yeah, that wasn't what I asked, but is everybody cool with the definition?
Pretty lit.
Okay. So if you see a line that only touches the edge of a circle once, it's a tangent. All right? That line is extremely important in calculus. That line is the basis of calculus. All the higher level math, the reason that we can go and send a probe to Pluto is based on tangents.
Our probe goes up your butt.
Everybody cool? No, that would be what is called an anal probe because it is probing your anus.
The Pluto drone.
Okay? You can also probe, for example,
An earlobe,
yes,
a nose,
yes.
throat, a mouth.
So, everybody now take your protractor and do the measurement of angle QAB. So you need to measure QAB. Now, everybody technically has a different angle here, don't they? Your radius does not go to the exact same spot in the circle as mine, does it? That would be impossible. But we do know that all of you drew a radius, yes? And all of you drew a tangent, yes?
Yeah.
So when you measure this angle, what do you get? You get 90 degrees. What does that prove to all of us for every single circle? That the angle between any tangent and a radius is what?
90 degrees.
90 degrees. Now, take your ruler and connect Q and O. What does that give us?
Triangle.
What kind of triangle?
Right.
A right angle triangle. This allows for Pythagoras. Is everybody cool?
Cool in the game.
Everyone's cool? Yeah? Okay, that's lesson 1. I want you to turn back in your notes to tangent, properties of tangents in a circle. Find this spot first. Okay? What's this guy?
Radius.
He's a radius. What's this guy? He's a tangent. This radius is useless to us. Yes?
Sure.
But this radius makes what?
Right angle.
A right angle. Everybody got it? So what's the rule? What are we going to write in here in our tangent? Or in the box there? What does it tell us? Because remember, math's all about making rules. So what do we get to write there? Right. Touches. If a radius intersects a tangent, it makes 90 degrees. What does this mean? This allows Pythagoras. Cool? So, let's do this. BP is a tangent, OP is a radius. So what does that automatically make this angle? 90. Which means X has to be what? 40. Angle OPB must equal 90. So X must be 180 minus 90 minus 50, which is 40. Is everybody cool? Oops, dumbass. Not you guys, me. All this work is up here.
I'm gonna go buy it though.
OPB equals 90. So X equals 180 minus 90 minus 50. So X equals 40. Moron. Not you guys, me. Down here is where you got to do that work.
Stop touching each other.
What's the answer here? It will require you to do some subtraction. Perry's not so hot at that. He's already told us.
Dang it.
He's only good at adding. So you'll want to pay special attention here, right, Perry? That's why I did all the work right here to show you how to do it. Because I care.
Oh, dang.
So what's the 90 degreer here? OCD. So angle X must be 180 minus 90 minus 65, which makes angle X what? $25. I know that's subtraction. That's subtraction, man. It's woo!
That's why we're in summer school.
It's tough, that subtraction. Everybody good? All right. Now we'll do some Pythagoras. Remember, Pythagoras is what? You were taught it. A squared plus B squared equals C squared.
Oh, leg.
Remember, leg 1 squared plus leg 2 squared equals C squared, yeah?
What's the difference, like, leg and...
Because you guys can't do it if the letters change. Okay. So, MB is a tangent, OB is a radius. So what is this angle right here? 90. What does that make OM? OM is what? Don't say 10 centimeters. What special part of the triangle is it? No, OM is not the right angle.
The hypotenuse.
OM is the hypotenuse. I know OM. So what are my two options for Pythagoras? It's either leg plus leg is hypotenuse, or hypotenuse squared minus leg squared will get me the other leg. So what am I doing here? Plus or minus? Minus, right? So it must be this one. H squared, 10 squared, minus the other leg, 8 squared, will get me R squared, right? Because I want the radius. What's 10 squared? 100. What's 8 squared? 64. What's 100 minus 64? 36. What's my last step when Pythagorasing? Square root. So what is R? 6. Is everybody good with that? So what we learned from the circle diagram is two things. We learned we can find all the angles, and we learned we can find all the measurements when there's a tangent and a radius. Cool? Everybody good? Okay. Now I am going to assign these next few pages. This is going to be your work. Okay? We're not going to go through it. That's going to be the work you're going to do. Everybody good? You're not going to start it yet, though. Everybody cool? All right. Go back to your diagram. Now, all of you should have a half a circle that is pretty blank, yeah? Yes? Everybody has that, yeah?
Yeah.
We are going to focus on that blank part of the circle. Okay, everybody good? So I'm going to go ahead and I'm going to label this guy as C. So I've got OC. What do I know? OC is a radius. Everybody got that? All right. Now, draw another radius anywhere on your blank half of your circle. It doesn't matter where. I'm going to put mine here. And label that guy D. So what do you know about OD?
Over the.
OD is a radius. OD equals OC. And on your guys' paper, they are both 8.7. Cool? So what can I do to these two lines now in geometry? I can mark them because they're the same. Yes? Everybody cool? News to anyone? News to anyone? No. We've already done that, yeah? So now connect CD. CD is a chord. Okay? A chord connects 2 points inside a circle. Now, what shape did I just make when I connected those two radii? I made a triangle. What kind of triangle?
Isosceles.
Isosceles. Why?
Those two sides are.
Because all the radii are the same. So what does this shape tell me about angle ODC and angle OCD?
The same.
They're the same, aren't they?
Yeah.
Because it's an isosceles triangle.
OCD.
Everybody cool? Everybody good? Yeah?
Yeah.
Okay. Next thing I want you to do, and it's getting crowded, but it's the last thing we're going to do. You should still have some space over here on the A side of your circle. Does everybody have that space? Great. Draw the radius OE.
Draw the line.
Yeah, draw the line. Draw another radius. OE. Everybody cool? Yeah, yeah? Yeah, yeah?
Yeah.
Yeah, yeah. All right.
Yeah.
Now, draw AE. What did I just make with AE?
Triangle.
A chord. right? I made a chord, which then gave me a triangle, right, Paneet? Okay. Tell me the measurement of AE. No. AE. You got to measure it with your ruler. Measure it.
Oh, mine's very large.
Doesn't matter. I want it to be a different number than everybody else.
12.2.
Okay.
12.4.
Whatever you have, write its measurement. Okay? And then I want you to put a dot in the middle. So mine is
Mine's 13.
8.4 centimeters. Mine is 8.4, so half is 4.2. Okay? Label that midpoint F. Is everybody cool still? So what does that tell us about AF and EF? What are they? They're going to be, for me, 4.2, yeah? But they're going to be the same, aren't they? Right? So F bisects AE. Bisect means cut in half. By 2. Cool? Everybody good with that? Now the last thing you got to draw is a radius through F. The radius has to go right through F. Then measure that angle. And what do you get? What's this angle right here? Angle.
Nice.
90 degrees. So what does that tell you? Because everybody's got different triangles, don't you? If a radius cuts a chord in half, what will it always make? 90. If two radii are joined by a chord, what will it always make? An isosceles triangle. Everybody cool? Okay, now we're going to do the notes for that, which are right here. Once we do those notes, I'm going to let you free to do the work, okay?
What's that for?
That font is called cast iron. So over here, in this drawing, draw me a radius and a chord. Where do the radii go?
Oh, to the time.
Where do the radii go? From the center to where?
Anywhere.
Center to the side. There's a radius. How many of them are there?
Infinite.
Infinite. Now draw me a chord anywhere in there.
Did it
Where does chord go?
on the like,
Edge to edge, inside the circle. Anywhere.
makes sense.
There is a chord. Everybody cool? Now, we have learned two things about chords, haven't we? The first thing we learned two things. The first thing we learned is this. Radii and chords make what kind of triangles?
Right angle.
No,
Oh, I saw something.
isosceles. So if I take two radii and I'm working in red, that gets me an isosceles triangle, yes? Which means, what do I know about these two angles?
The same.
They're the same. Cool? But it also gives us a second piece of information, right? Chords bisected by radii make what?
90 degrees.
Make 90 degrees. So over here, I'm going to draw a chord. I'm going to cut it in half. So this side equals this side, and I'm going to draw that radius. What does that give me? 90 degrees. Everybody cool with the two things we now know?
That's science for you.
It's actually math for you, but it's useful in science.
Yeah, that's what
Can't do science without math.
I got 92% science.
You can do math without science.
Very good at science.
Okay?
I'm trash.
So here we have this. I'm going to make this a little bigger so it's more visible for you guys. So what do I have there? Write down everything I have. Do I have some radii? What are they? O. OC is a radius?
OA.
OA is a radius. And what's the other radius?
OB.
OB. Those are my radii, yes? Okay. Now, Perry, what would I have to do to OC to make it a radius? No, to make it a radius. Where does a radius have to go? To the edge. So if I extend this to D, do I now have a third radius? What is it? OD. Everybody cool? All right. So now this is going to tell us some business, right? These little symbols mean I'm only looking for degrees, yes? If I'm looking for degrees, does Pythagoras help me?
No.
No. So the first thing I say to myself is degrees means no Pythagoras. All I got to do is find my degrees. So, what do I know? OA and OB share a characteristic. What is it?
The same.
They're the same. So what math goes in there? What symbol goes right between them to show they're the same? Equals. What do I get to do on the drawing? As soon as I know something is equals, I get to mark it. Once I mark it, I have an isosceles triangle, don't I?
Yeah.
So what's angle Z?
I cannot see. 30.
30. Because if these two are the same, the bottom angles must be the same, correct?
Yep.
Everybody good? All right. What else do I know? What do I know about AC and BC? They're equal, which means chord AB is bisected, yes? Once we know it's bisected, what do I know about that angle?
90.
It's 90. So X must be 90 degrees, right? Because this has been bisected. Everybody cool? So does that allow us to know what Y is?
Yes.
What's Y automatically? No. 60.
Yeah.
Y is Y60. Because X is 90, Z is 30, 30 and 90, Y is 180 minus 30 minus 90 to get 60 degrees. Everybody cool? Excellent. Turn the page over.
I know that first.
So now we look at this page, this side. Do you see anything about angles? Do you see anything about angles? Do you see anything about angles?
Yes, 90-degree angle right there.
in the question.
Help.
Find the length. I'm not finding angles. So, when there were angles, there was no Pythagoras, but now there's no angles. So what does that mean? Pythagoras. Okay? Pythagoras is for measurements. If you need to find a measurement, you need to do Pythagoras. Okay? So, what do we know about this? Since these two are the same, because that's 90, I know I can do Pythagoras here, can't I? I want the length of chord AB. Can I find that? How? By doing Pythagoras with what? With 6, 10, and this is what? I don't know, right? So we can make it x. Now, I wouldn't make it x. I would make it what? Because we're doing Pythagoras. A leg, or if you're actually good at it, you can call it A, B, or C. B or A. Right? Cannot be C. I'm going to write it as a leg. So because I have a hypotenuse, am I doing the add or subtract Pythagoras? I'm doing the subtract. So 10 squared minus 6 squared will get me L squared. 100 minus 36 gets me L squared. 64 gets me L squared. So what's L? 8. Have I answered the question?
No.
No, because there's 8 here. Because this is 90, these two have to be cut directly in half, don't they? Right?
Yeah.
So if 8 is half of it, what's this half? So what's the whole thing? AB equals 16. Cool? Gouda? Practice it once here. I need to find A and B. Remember, you don't need to use all the blanks. This is showing plus, isn't it? So, A plus B is C. Why did I reverse the order? Because it doesn't matter, right? And you got to subtract. So if I put in C, 13 squared equals B squared, which is 5 squared plus A squared. Now to do algebra, you know you've got to do minus. Yeah?
Yeah.
So that's 169 minus 25 equals A squared. 144 equals A squared. What's A? 12. So A equals 12. What do I know about A and B because of this symbol? That A has to equal B. So if A is 12, what's B? 12. Got it? Good. Do the practice, which is the next 2 pages of this. So what's your work right now? The first 2 pages that we stopped at after tangent radius. These ones, where it says practice, right here. And then where it says practice, right here. I'm not giving you any textbook work, just work on these sheets. Work together, use your notes, do what you need to do. Okay?
Okay.